it would take less time for this ventricular pressure to overcome that. Make sense? So if it takes less time, then the ejection phase is a little more prolonged. So if the afterload is low, what happens to your stroke volume?
Say that again.
Everything I said already.
No, the question. The question
is, if your afterload is low, and it takes less time for this ventricular pressure during phase 2 to build, to overcome that afterload, now you actually have a shortened phase 2 and a longer phase 3.
Mm-hmm.
So if that's the case, do you eject out more blood or less blood? More blood. So if your afterload is low, your stroke volume increases. Because it takes less time for it to shorten adequately to overcome that aortic pressure to eject out the blood. Make sense? Now, what if your afterload is high? If your afterload is high, then phase 2 is actually shifted all the way here. Make sense? So now it takes longer for you to build up enough tension to overcome the aortic pressure. So then what happens during phase 3 then? It decreases. Now, what electrical activity is going on in phase 3 of the cardiac cycle? So you have P wave, QRS complex, T wave.
Ventricular repolarization.
So this is not gonna wait for you. The electrical signal will proceed the way it has to proceed. So therefore, if you shorten this phase 3, then you will actually lose a little bit of time during the first half of the ventricular ejection phase. And remember, we talked about the first half of the ventricular ejection is the rapid ejection phase. So during that first half, you're rapidly ejecting out a lot of volume into the aorta. But if you take more time in phase 2, that means you have less time in the first half of phase 3. So then you'll end up ejecting less blood into the aorta. So therefore, if you increase the afterload, what happens to your stroke volume? It will decrease, right? So the afterload is inversely proportional to the stroke volume. If you increase the afterload, you will decrease the stroke volume, and vice versa. Okay. So if you decrease the afterload, you will increase the stroke volume.
So the higher the TPR, the slower the contraction, the less stroke volume.
Well, just think about it this way. Let's measure stroke volume as the amount of reps that you can do in dumbbells, right? So if you take a 5-pound dumbbell, that's a very small load, so therefore the afterload is low. How many reps can you do in a minute?
More than if it was.
Let's say 100. We're going for broke, right? Do like 100 reps, okay? If now you take a 50-pound dumbbell, how many reps can you do in a minute? Exactly. Let go. So let's say 5, right? I mean, we're giving ourselves a boost of an ego here, right? An ego boost. So therefore, let's say 5. Now 5 compared to 100, that's significantly lower. So that means the higher the afterload that you have to overcome that. It takes longer for you to generate tension to overcome that. In the heart, you cannot recruit. There is no recruitment. There is no graded type of contraction. It's an all or none contraction. It is a functional syncytium. So when the ventricles contract, the whole ventricles contract. It's not like, you know what, there's a little bit of volume, there's a very small afterload. Let's say only half of the ventricle contract. No, it's still the whole thing contracting. But it's just contracting faster now than if you have a much higher afterload, then it takes longer for it to contract completely. When this happens over time, what's gonna happen to the myocardium of your ventricle? The muscular walls of your ventricle? It's going to get bigger. Because you're basically forcing your left ventricle to work out every single minute, or actually second of its life. Imagine you working out every single second for 90 days, let's just say, like, you know, not even like whatever age you are now, for 90 days, you're gonna get really big. The heart is doing that constantly, every single second. If you have hypertension, let's say from the time you're 18 years old to the time you're 40 years old, that's almost 20 years. Every single second of 20 years constantly working out. imagine how hypertrophy your heart would be. Okay? This is why hypertension is known as the silent killer. This is the reason why hypertension keeps all of us in business, unfortunately. Right? Because hypertension is the #1 medical condition in America, if not in the world. Okay? So if you have hypertension, or you know anybody that has hypertension, you must correct that hypertension. Otherwise, your cardiac activities become irreversibly damaged. At some point, you cannot change that anymore. You can't correct that. You can't reverse that process. Okay, so afterload, or the total peripheral resistance, is inversely proportional to the stroke volume. Okay? A third factor that can affect the stroke volume is what we call inotropy, which essentially means contractility. Okay? So, if you contract the heart harder, you reject out more volume. If you contract the heart less so, you reject out less volume. Right? How do you stimulate, or how do you change this contractile strength of the heart without putting in volume? Sympathetic activities. So as you increase the sympathetic activities, you will increase the strength of the muscle contraction. This is independent of the amount of blood that is inside your heart. For this type of contraction, this is dependent on the amount of volume of blood in your left ventricle. Okay? So when you apply the end-diastolic volume to increase the stroke volume, we call this length dependent inotropy. When you stimulate the muscle of the ventricles through the application of the sympathetic activities without that additional volume deposition, we call this length independent inotropy. What's that length? What is the length referring to? The length of the sarcomere. Okay? So if you apply more blood, you put more blood into the left ventricle, the sarcomere stretches out, therefore it lengthens the sarcomere. And as the sarcomere lengthens to its optimal length, it will produce a very strong contraction to eject out more blood. So that's called length-dependent inotropy. That is what the end-diastolic volume is going to give you. Okay? This one is just simply applying the sympathetic activities to this cardiac muscle cell and allowing it to contract harder. When that's the case, this is known as the length independent, because you don't need to stretch the heart, you just stimulate them to contract harder. And as it contracts harder, it will increase the stroke volume. So with the length independent inotropy, again, if you increase that, you increase the stroke volume. Okay?
So inotropy.
Inotropy. Yeah.
Can you say that again, please?
Inotropy.
Inotropy is more about the strength of the contraction, while a TPR is about speed.
No. Well, TPR, or the total peripheral resistance, is basically affecting the shortening velocity of the sarcomere. Yes, the speed of which the sarcomeres can shorten. All right. Whereas this is just basically based on the overall strength of that contraction itself. Okay. So if it's sympathetic activities, right? This sympathetic activity, how do you produce inotropy in the heart? Is it at the SA node? Is that at the AV node? Or is it in the myocardium? So do you directly stimulate the contractile cells, or do you have to stimulate the autorhythmic cells? No, you automatically stimulate the contractile cell. So it's a direct connection to the contractile cells of the heart to allow for this inotropy to happen. So here's your contractile cells. in the myocardium. When you apply sympathetic activity, this is sympathetic nerve. What neurotransmitters do you release? It's the other one, Anton. The one that you liked.
See, I mixed up sympathetic and parasympathetic.
Well, fix it. So this would be norepinephrine and epinephrine. Okay. Good. If it's norepinephrine and epinephrine, what receptors are located on your contractile cells? What if I tell you this norepinephrine and epinephrine binds to a type of receptor on these contractile cells that will activate the cyclic AMP pathway? Which one is it? Alpha or beta receptors? If you guys don't know what these terms are, then you weren't paying attention when we were talking about the autonomic nervous system. So which one? Alpha or beta? And in alpha or beta, is it alpha 1, alpha 2? In beta, is it beta 1 or beta 2?
Beta 1.
So is it alpha and beta? Which one? Beta? Okay, good. Which one is it? Beta 1 or beta 2?
1.
Beta 1.
Are you sure?
Yeah. Beta 2 is inhibitory.
Yeah.
I mean,
They're both excitatory.
really?
Alpha 2 is inhibitory.
I thought alpha 2 ended being.
Alpha 1 is excitatory because alpha 1 uses the calcium calmodulin pathway. Alpha 2 uses the inhibitory pathway of the cyclic secondary messenger.
I remember beta 2 having like some kind of an inhibitory.
They're both excitatory. How about here between the pre and the post ganglionic neurons? It depends on where you're looking at. So if we're talking about the heart, no, they're both excitatory. Well, I mean beta 1. Beta 2 is not in the heart anyway, so it doesn't matter.
Yeah.
So what neurotransmitter is released between the pre and the post ganglionic neuron? Acetylcholine. And what receptors are found in the post ganglionic neurons that bind to that acetylcholine? Nicotinic receptors. What's this ganglion called? I should make the final exam comprehensive.
Terminal.
Terminal is only for parasympathetic. I know you guys don't want to hear it, but physiology is connected together. It's not isolated, guys. You can't learn one thing and then forget about it, and not think about it when it comes to something else. So there's only 3 different types of ganglion, right? Paravertebral ganglion, prevertebral ganglion, or the adrenal medulla. This is not the adrenal medulla, so you can scratch that. Now you have 50-50. Think about it and get back to me. Otherwise, this becomes an extra credit question on your exam. Okay. All right, so any questions about these factors? So the 3 factors that influence stroke volume directly: end-diastolic volume or your preload. Inotropy, which is basically length-independent inotropy, and total peripheral resistance or your afterload. Okay? So if you want to increase your cardiac output, the best way is to do what? What does that mean? Why does exercise increase your cardiac output? Because it's sympathetic. That is the answer, not exercise. You can apply the sympathetic activities. When you're scared shitless, that's not exercise, but that's the sympathetic activities. And when you apply the sympathetic activity, it increases the heart rate, it increases the venous return, which increases the end-diastolic volume, it increases the inotropy of the heart, and therefore increase the stroke volume. Increasing stroke volume, increasing heart rate, increases cardiac output. That's how we work. Okay? So therefore, learn this pathway and understand if we change these factors, how does that ultimately affect the cardiac output? That's what you guys need to know. That is cardiac physiology. Right? This is how it works, the heart, and all of these particular things, that's how it works. Okay? Questions about this? All right, have a good night.